Hi, welcome to today's video on basic architectural acoustics. So welcome to this video. Let's begin. Okay, so in the last class you guys learned about reverberance and reverberation time. Today we're going to talk about room treatment and many other topics. The first thing that comes to mind when we talk about room treatment is how do we achieve the particular type of acoustics we need for that room. Suppose it's a recording studio, or suppose it's a home theater or a cinema. How do you achieve the acoustic parameters for that room? That's what we're going to discuss now. The first thing to keep in mind while applying room treatment is to understand whether the room is mainly used for speech, for music, or for both. Second thing is the volume of the room, because the volume of the room is directly proportional to the reverberation time. The more the volume, the higher the reverberation time. The geometry of the room. The geometry of the room can affect the acoustics. Some shapes can focus sound and some shapes can diffuse sound, and that's where the geometry of the room is very important. And also trying to avoid parallel walls results in reduction in flutter echoes. In room acoustics, there is something called room resonances or room modes. In high school physics, you might have had a long pipe with closed on one end, and you use a tong, and you play some particular frequency of sound, and you hear a loud noise. This is the same principle with rooms as well. The room modes are standing waves in a room. This analogy is similar to what you learnt in high school physics. So here on the bottom left you can see the first type of mode, which is the strongest mode of resonance, that is called axial mode of resonance. The second one in the middle is known as a tangential mode of resonance, and the last one is known as the oblique mode of resonance. So the axial mode of resonance is the strongest. The tangential mode of resonance is the second strongest, and the oblique mode of resonance is the third strongest. So usually in room acoustics you would be more concerned about axial resonance. One thing you have to note about what happens in acoustics is that at the walls or at the boundaries, the sound velocity is 0, but the sound pressure might not be 0. Here you can see peaks and dips. The places where there are dips are known as sometimes known as dead spots, because the loudness in those spots is very low. So this is about room modes and room resonances. This is particularly important in the low frequencies. The placement of your subwoofer is dependent on the shape of your room and the room modes that can exist in that room. Now let's talk about acoustical tools and measurements. In the last video you saw me using my sound level meter to measure reverberation time. The device that is used to measure sound pressure level is known as a sound level meter. If it has some advanced functions, it is also called as a sound analyzer. It consists of a microphone. The tip of this instrument, there is a microphone, and the rest of the stick is the preamplifier, and the main body of the sound level meter is the brains. It is also known as a sound analyzer. Sound level meters with advanced functions have features where you can measure decibel levels in 1/1 octave bands or 1/3 octave bands, or sometimes even 1/6 and 1/12 octave bands. These are known as sound analyzers. Some sound analyzers have an option of measuring reverberation time also, like my sound level meter, which I demonstrated in the last video. Now let's talk about one important parameter that we need to understand in room acoustics, that is speech intelligibility. Suppose there is an auditorium or a lecture hall. The speech intelligibility in such a space is very important. It is also important in say classrooms, and especially important for classrooms for young children. Our ability to understand words and sentences in a particular room is known as the speech intelligibility. It is dependent on the background noise, the reverberation time, the shape of the room, etc. There are different methods to evaluate speech intelligibility. Two common methods are articulation index and speech transmission index. Articulation index has two definitions. One is the audiology definition and the other is the acoustics definition. Here we are only going to talk about the acoustics definition, and then we're going to talk about speech transmission index. So articulation index is a measure of speech intelligibility influenced by the acoustical environment of a particular room. It is rating from 0 to 1 or 0% to 100%. The higher the number of sentences that are heard correctly, the more the speech intelligibility. In articulation index, what they do is they speak some nonsensical sentences such as pim dim dom or something like that, and they ask listeners to write down the sentences they have heard. The amount of correct sentences to the total number of sentences is the articulation index. An articulation index of less than 0.3 means the speech intelligibility is almost non-existent or very poor. An articulation index of more than 0.7 means there is a good speech intelligibility in that space. The second most common parameter used to measure speech intelligibility is a speech transmission index. The speech transmission index is more for amplified speech, that is speech where loudspeakers are used or sound reinforcement systems are used, whereas the articulation index is used primarily for unamplified spaces, that is where there are no loudspeakers or AV systems. So the speech transmission index is also similar to the articulation index. It is a number from 0 to 1. Anything above 0.6 or 60% is good speech intelligibility, and anything below 0.3 is very bad speech intelligibility. The noise source that is used for testing begins at 125 Hz band and goes up to the 8 kilohertz band. A particular type of sound signal is played. It is called a STI-PA public address STI public address signal, and that signal is played through the audio systems of the auditorium or the space that we are measuring the STI in. The sound level meter is placed at different positions in the enclosure, and based on some algorithm, the sound level meter determines the STI at different places. So speech transmission index mainly used for public address systems. It is an alternative to RASTI. RASTI is an old speech transmission index standard which is called rapid speech transmission index. We are not going to go any further into that. So speech transmission index is mostly used for public address systems, whereas articulation index is mostly used for unamplified spaces. So before we talk about noise reduction coefficient, let us briefly discuss what is the absorption coefficient. The amount of sound energy absorbed by the amount of sound energy incident on a particular surface is known as sound absorption coefficient. The sound absorption coefficient is different at different frequency bands and different frequencies. To give a single number rating to sound absorption, the industry people have come up with something called the noise reduction coefficient, or the NRC. This is the average of the absorption coefficients at 250 Hz, 500 Hz, 1000 Hz and 2000 Hz. Here I have given a numerical example of calculating the NRC. The NRC is always rounded to the nearest multiple of 0.05. So here you can see at 250 it's the absorption coefficient is 0.23, at 500 it's 0.7, at 1000 it's 0.86, at 2000 it's 0.89. If you average these four values and round it off to the nearest 0.05, then you get the noise reduction coefficient, or the NRC. There is one more thing called noise criteria, or noise criterion. This is a single number rating for background noise or ambient noise. If you've seen before, the NRC, if you have seen before, the NRC is the single number rating for sound absorption coefficients. The NC is the noise criteria, or NC is the single number rating for background or ambient noise. Here you can see several NC curves which are almost offset from each other, and you can see a black line here. This black line is the measured background noise. Here you can see that the black spectrum just about touches the yellow curve, that is NC40 curve. Therefore this particular background noise would be classified as NC45. We always take the higher value with respect to noise criteria, so the noise criteria in this particular room would be classified as NC45. This is a blown up image of the same thing. Here you can see the black line as it's a noise spectrum. It just crosses the NC40 line. So the next to NC40 is NC45. So the background noise level of this enclosure or this space is NC45. NC or noise criteria is a single number rating for background or ambient noise. In the next class, we are going to talk about the various types of absorption materials. So thank you very much for listening. I hope you enjoyed this video. For more videos, please give us a thumbs up, and please do subscribe, like and share. We always appreciate comments. We would like your feedback, so please do leave your feedback in the comment section. Thank you very much.